All right. Here we go. This is the last one, chapter 7 of trigonometry on our final exam review. This was all about solving equations, and it really related back to an earlier chapter. I can't remember off the top of my head. I think it was, yeah, it was this chapter. All right. So this had a lot to do with chapter 3, but we just had a few more steps involved. It was basically solving these trig functions or these trig equations, doing a little bit of algebra before, kind of looking back at the unit circle or using those inverse equations. All right. So these first ones we had arc sine, which remember was the same thing. So arc sine, one, it's the same thing as inverse sine. All right. So if you want to say arc sine or sine inverse, whatever you want to do, those mean the same thing. We had to be careful on these because a lot of times, remember, with when you have your sine function, we know the sine of some angle is equal to the opposite over the hypotenuse. And a lot of times on these problems, like in geometry or early days of trig, we give you the angle and we give you either the opposite or hypotenuse, and you have to find the other one. The whole reason for the inverses is, well, what happens if I give you two side lengths on a triangle? What if I give you both the opposite and the hypotenuse, and I ask you to find the angle? How do we do that? Well, we do that by taking the inverse. So we say the inverse sine, or the arc sine, of that ratio of the two sides, the opposite over the hypotenuse, that equals the angle that we are looking for. So that's the inverse sines here. Now, when we think of these things as functions, we have to restrict them, because if you think about a sine function looks like this. All right, and it kind of goes on forever, right? It does this squiggle thing, it goes on forever. But if you look at the uh, inverse of that, and if you think back to like algebra 2, algebra 1, the days of inverses where you switch x and y, solve for x, you solve for y, whatever, um, it kind of reflects over the y-axis. And it turns out that the sine inverse function, I can't remember exactly off the top of my head, but it looks something kind of like this. All right. And if you think of how functions work, they can't curl back on themselves because they fail the vertical line test. All right. So what we do is we restrict it. All right. So we only look at this section here. So arc sine, we say, is only defined between negative pi over 2 to positive pi over 2. All right. So that's how we kind of define what the arc sine is. We kind of have to set restrictions or boundaries on it. And similarly, we can do the same thing for cosine. So we say the arc cosine, or cosine inverse, right? We can restrict this one from 0 to pi. And then with tangent, same kind of thing. Arc tangent, inverse tangent, again, same thing. We're going to restrict this one to negative pi over 2 to positive pi over 2. Right? And what that looks like on our unit circles is everything that has an arc sine can only be in quadrants 1 and quadrants 4. Everything that is an arc cosine can only be in quadrants 1 and quadrants 2. And the last one, the arc tangent, the only answers we can get are in 1 and 4, just like the arc sine. Right? So with that in mind, let's look at some of these problems here. They're asking for the arc sine negative square root of 2 over 2. All right, so this is just go to the unit circle, find negative 2, what was it, negative square root of 2 over 2. All right, so negative square root of 2 over 2, notice how, well, let's see here, where are we here? I see a negative square root of 2 over 2 right here, but this is in quadrant 3. All right, the inverse sine or arc sine is not defined in quadrant 3. We're not allowed to have any answers in Q3. So the only acceptable answer here is going to be this one, which if you notice, it's 7 pi over 4. Um, but 7 pi over 4 is not between our boundary of negative pi over 2 to positive pi over 2. So what we have to do is we have to find that coterminal side here. So if we want to think about it, this 7 pi over 4 or 315-degree angle, that's no good. So it's not 315. It's going to be 360 minus, I got that backwards. It's 315 minus 360, right? We have to have that negative number here, and that gives us negative 45, right? So if we were to punch this into our calculator, a lot of times we say no calculator allowed in the section, but if I do punch this into my calculator, we're going to say the inverse sine of negative square root of 2 divided by 2. And that should give us negative 45. Fingers crossed, it does. So I guess really on a lot of these things, you can just punch them into your calculator and see, or just identifying the unit circle, all right, like this one. This one is the inverse cosine. We know the inverse cosine is not defined in quadrants 3 and quadrants 4, so our answer has to be somewhere on the top of the unit circle. So look for that negative square root of 3 over 2 right here, and that green one, that's at 150 degrees. All right, and inverse tangent. So inverse tangent, we said, is not defined in quadrants 2 and 3. So the answer's got to be either in quadrant 1 or quadrant 4. So look for that positive square root of 3. It's going to be right here. That gives us a 60-degree angle. Now, if you did want the radians, you could. This is going to be negative pi over 4. This one is, oh, what is that, 5 pi over 6? And this one's pi over 3. All right, so you could do degrees, you could do radians. It just kind of depends on what the question is asking. All right, and the next one's the same process. Again, where is arc cosine defined? It's only defined on the top, so look for that negative square root of 2 over 2. That's going to be right here at 135. Right? The inverse cosine of 0. So where is cosine going to be equal to 0? That one ends up being right on an edge, right? It's not in a quadrant, it's on the y-axis there. So that one's at 90 degrees. And the last one, the inverse tangent of negative 1. One more time, tangent is only good in quadrants 1 and 4. So find negative 1, which is right here. Quadrant 3, that gives, I'm sorry, quadrant 4 gives us 315-degree angle. But I can't do 315 because it's only defined between negative pi over 2 and pi over 2, or negative 90 to positive 90, right? So that angle goes right here. So this is a negative 45-degree angle, right? But there we go. That should do it on this section here. Let's write this one in here as well. Negative 45. So that's 1 through 6, and then the next two going to be more of the same. Find the exact value. So again, arc cosine. The first thing you have the sine of the arc cosine of 1/2. So start with the inside and kind of work your way out. So the first thing you should really focus on is this guy right here, the arc cosine. And again, arc cosine is only defined on the top. So you need to figure out, hey, where is arc cosine equal to 1/2? And that looks like a 60-degree angle. Okay. So arc cosine, I'll try that again. Let's be red. Cosine of 1/2 equals 60 degrees. All right, so basically what I'm looking for is I'm looking for the sine of 60 degrees. What is the sine of 60 degrees? Well, just go to the unit circle, and that's going to be square root of 3 over 2. So if we wanted to throw all that into our calculator, which we could, get 1/2, should spit out as 60, hopefully. Right, which it doesn't. That shouldn't spit out as 60, it should spit out this decimal. But that decimal is the square root of 3 divided by 2. That is that same exact decimal here. That's how we get the exact values. All right. So, like on the next one, we are looking for the arc tangent. First, arc tangents only defined in quadrant 1 and 4. So the inverse tangent or the arc tangent, remember that means the same thing. We have to find this value on the unit circle first, which is going to be right here, 330. And again, not 330. The coterminal side has to be the negative. So that ends up being a negative 30-degree angle. Right? So the cosecant of negative 30, right? Or if you wanted to think about this, this is 1 over the sine of negative 30. Figure out what that value is. And negative 30 is going to be 2. So this is 1 over negative 1/2, which gives us 2. All right. Now, the next one, find the exact value. They are asking us basically, we're going to have to do the Pythagorean theorem. So again, arc sine. Where is arc sine defined? Arc sine is only defined in quadrant 1 and quadrant 4. So they're telling us the opposite over the hypotenuse is this way. And that's a positive number. Sine is only positive in the first quadrant. All right, so you have a 3, you have a 5. Using your Pythagorean theorem, we can get this as a 4. Right? So basically, what they're saying is this arc sine, they're kind of defining this angle right here with that 3 and that 5. Right? So now basically what they're saying is using this same triangle, find the cosine of this angle. Right? Well, the cosine of theta is just equal to 4 over 5. Right? This part right here, this arc sine of 3/5 is equal to some angle, right? And that angle is going to be the same angle that we're going to use along with cosine. All right, so we're just getting the ratios on this one. Right? And the last one here, the inverse cosine. Inverse cosine is only defined on the top half. So we have a negative 12 over 13. And keep in mind, it's going in the negative direction. That is the adjacent over the hypotenuse. So you have your negative 12 here. You have your 13 here. Right? This angle on the inside is your theta. And they're asking us to find the tangent. Well, in order to find the tangent, we need to use Pythagorean theorem again, figure out this number here. And that ends up being a 5. I'll let you guys work through that one. But the tangent is the opposite over the adjacent. All right. So the tangent of theta is equal to 5 over negative 12. Let me try that again. 5 over negative 12. That's better. All right. There we have it. That was the first page of Unit 5. School starts in about 15 minutes, so I don't think I have time to do this last page, but we're almost done. So see you guys in the last video.